With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's see the following question. An ideal equimolar binary liquid solution of A and B has a vapor pressure of 900 mmHg. It is distilled at a constant temperature till 2/3, that is 66.67% of the original amount. The mole fraction of A is 0.3 in the residue and that of B in the condensate is 0.4. And also vapor pressure of the residue is 860 mmHg. Which of the following is correct statement? So let us write the given data first of all. So it is, we know that the pressure of the full solution in ideal, for ideal solution, this is for ideal solution. So for ideal solution, we know that pressure of the solution is equal to pressure of a component A and pressure of component B. So pressure of component A is its vapor pressure in pure form into mole fraction, plus pressure of B is its pure pressure into its mole fraction XB. Okay. So now that we know the residue it is given as, for the residue, let us write, it's told that the mole fraction of A is given. For the residue, mole fraction of A is 0.3 in the residue. So let us take this as X dash A, because it's a residue, 0.3. So definitely X dash B will be 0.7. How do we write the equation now? As we'll treat it in this equation. Pressure of the solution is equal to 0.3 into, okay, 0.3 into P naught A plus 0.7 into, we can write into P naught B. Let us take this equation. So this is given overall as 860 mmHg. For the residue, pressure is given as 860 mmHg. So this is 860 mmHg. So let us take this equation as equation 1. Now let us go ahead. So as it is told in condensate, the mole fraction of B in condensate is 0.4. So I am going to take it as, for condensate, this is in condensate. In condensate, mole fraction, that is X double dash A, let us take it as, okay, this is 0.4 it is given. So X double dash B should be 0.6. Okay. So this is the whole thing. Now condensate's full pressure is not given, but an ideal equimolar binary liquid A and B has a vapor pressure of 900 mmHg till the constant temperature 2/3 of the original amount. So how can we solve this? So now we know that the mole fraction we don't know. So mole fraction of A initially we don't know. Let us take it as X. Similarly, mole fraction of B initially we don't know. Let us take it as Y. Okay. So we know that what is X? X is its residue plus condensate. So residue plus condensate, how to solve this? So residue, we know that it is 0.3, okay, into 1/3 of X plus Y. Okay. Similarly, 2/3 of X plus Y into 0.6. This is from the given data itself I am solving. So as we solve from here, the X value what we get is 0.5 into X plus Y. That is X divided by X plus Y will be 0.5. So we have understood that X is 0.5, Y is also 0.5. Let us use it in first equation. So in the first equation it is told that X is 0.5 into P naught A plus P naught B into 0.5. Let us take this equation as 1, 2. So from 1 and 2, what have you understood? From 1 and 2 we have solved. Okay. So from there we got it that P naught A will be solved as P naught A. We can cancel, we can divide equation 1 by 2. We get P naught A as 1000 mmHg and P naught B will be 800 mm Hg. Okay. So when we use it in the first equation, we'll use it in the first equation. So we can get it like P naught A into XA plus P naught B into XB is equal to pressure total. So P naught A we got it just now. It is 1000. It is 1000. XA in the initial we know that it's in the condensate we know that it is 0.6 plus 1000. Sorry, this is 800 into 0.4, which comes to be 920 mm Hg, because already it is given in the residue. The total pressure in the residue it is given as 860. So total pressure in the condensate we calculated in the last, that is 920 mm Hg. Okay. So we'll see the options. So mole fraction of A is more than that of B in vapor phase. Above residue has above residue as well as above condensate. So it's given that mole fraction of A is more than that of B in vapor phase in both above residue as well as condensate. So let's mark first residue and condensate. So this is A, mole fraction of A in residue. In condensate, the mole fraction of A is 0.6. Okay, so in one of the form, this is more. Okay, in the residue form, it is less. Means in both the options, in residue and condensate, in both they cannot be more. Okay, so as the vapors are vaporizing and the liquid is vaporizing like this, so if it is more in vapor phase, in the residue it has to be less. If it is more in residue, in condensate it has to be less. So it cannot be more in both the cases. So this is conceptually wrong. Okay, so option 2, vapor pressure of condensate is more than 900 mm Hg at the same temperature. So vapor pressure of A is been asked. Vapor pressure of condensate is more than 900. So condensate is here, isn't it? So we have used the formula. We got the value was 920 mm Hg. So it is more than 900. So this statement is true. In vapor pressure of residue, vapors of A is more contributing. See, vapor pressure of A, PA depends on the XA. Okay. So here in the first case it is equimolar, but in the residue and condensate if you see, its contribution is less. Now it is asked that vapor pressure of residue, we have to see the residue. In residue, vapor pressure PA, this is PA, depends on the mole fraction, but since it is less compared to B, it is not depending. Okay, so this is going to be not correct. So we'll see that if the solution would be distilled 50%, the original amount, the mole fraction of B in liquid condensate would be more than that of A in the same solution. See, this is not possible. Even if it is distilled at 50%, if the original amount of the mole fraction of B condensate would be more than that of A. So condensation, will see that in condensate actually mole fraction of B is anyway less. Even at distillation, since its mole fraction is less, in distillation it is going to be remaining less only. So this cannot increase. So this is also not correct. Therefore the right option here should be option B. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.